We have all felt the rush of vibe coding. You open an AI assistant, type in a loose idea, and within seconds, you're watching a prototype assemble itself on your screen. It feels incredible, right up until it collapses. If you keep prompting, you inevitably hit a wall. As the file count grows, the AI starts losing the plot. It forgets earlier instructions, overwrites working functions, and your context window completely breaks down under the weight of spaghetti code. You quickly discover the core trade-off of ad hoc generation. You save an hour on upfront planning, but you pay for it with endless hours of downstream debugging, trying to stitch broken logic back together. That endless cycle of prompt ping-pong might work for a quick single-file script, but it falls apart entirely when you try to apply it to serious, multi-file enterprise software. To build real, maintainable software, we have to stop treating AI as a chaotic chat assistant and start managing it as a predictable execution engine. That structural shift is exactly what GitHub's open-source Spec Kit is designed to do. It forces developers to step away from the chaos and adopt a process called Spec-Driven Development. In this framework, specifications act as executable blueprints. They directly dictate the final code, rather than serving as passive text that gets discarded once the coding starts. This diagram shows a side-by-side comparison of how you currently code versus the spec-driven pipeline. On the left, you have the standard ad hoc workflow, a chaotic loop of prompting, encountering errors, and experiencing architectural drift. On the right, you have a linear 5-step descending pipeline: constitution, spec, plan, task, and implement. Looking closer at that left side, every time the AI misunderstands a prompt, it generates flawed code. You re-prompt to fix it, which introduces a new bug somewhere else, and those compounding errors multiply until the entire architectural integrity of your project is compromised. The right side solves this by forcing you through structured, sequential gates. You cannot move to the next step until the current one is locked in. This prevents context loss entirely because the AI isn't allowed to generate a single line of code until it reaches the final step. Introducing heavy initial friction into the development process is the mechanism that makes high-quality code generation actually predictable. Spec Kit functions as an orchestration layer that sits directly on top of your existing IDE and LLM. This matrix illustrates its compatibility. Over 30 AI agents funnel data into a centralized Spec Kit hub. The trade-off is setup time. You must manually configure command aliases and profiles to connect your preferred agent. Once configured, you get standardized slash commands, like /SpecKit. This unifies your entire development workflow, meaning your team uses the exact same commands regardless of the underlying AI agent. Decoupling the development process from specific vendors protects enterprise teams. If a smarter model drops tomorrow, you simply swap the engine under the hood. The pipeline starts with the /SpecKit.constitution command. This creates a permanent document defining your project's governing principles, your coding standards, and architectural guardrails. The operational trade-off here is consensus. You and your team must rigorously define and document these rules up front before a single line of code is authorized for generation. Next is the /SpecKit.specify phase. Here, you describe the actual functional requirements of the feature you want to build. This phase forces you to intentionally ignore the tech stack. You focus entirely on user stories, outcomes, and business logic. Before moving on, Spec Kit introduces a crucial clarification gap. You trigger a command where the AI actively questions you about missing edge cases, forcing you to resolve ambiguities. By anchoring the AI to these strict, human-approved governance documents first, you physically prevent the model from hallucinating unauthorized features later. With the rule set, you run the /SpecKit.plan command. Here, the AI translates your abstract user stories into a concrete technical architecture for your stack. This flowchart visualizes the breakdown. The /SpecKit.tasks command fragments an abstract user story into technical components, connected by strict dependency arrows. As these fragment into a rigid checklist sequence, human review becomes your final gate to correct misunderstandings before coding. Finally, you run the /SpecKit.implement command. This triggers the autonomous execution of the validated plan, working down the checklist task by task. This shift creates a clear technical trade-off. At this final stage, you surrender line-by-line coding control to the AI agent, trusting the instructions you built and validated in the previous 4 steps. This 5-step workflow shifts the professional developer's role. You spend less time acting as a typist and more time acting as a systems architect and reviewer. Because no two companies build software the exact same way, SpecKit relies on an ecosystem of community extensions and presets to expand its core functionality. Presets allow you to customize how SpecKit behaves out of the box. You can override the default templates to enforce specific organizational compliance formats or regulatory standards across all your generated plans. This blueprint illustrates how you can bring entirely new capabilities into the mix. You can plug external modules directly into the main SpecKit pipeline, adding functions like syncing generated tasks or enforcing strict CI/CD rules. The enterprise trade-off is security vetting. Because these extensions are built by third-party community members, your security team must rigorously audit the scripts before introducing them to an internal environment. If you put in the work to vet and configure these tools, this extensibility allows SpecKit to map seamlessly to highly mature, rigid corporate project management workflows. The most common objection to all of this is the friction. Writing detailed constitutions, specs, and technical plans feels a lot like regressing to slow 1990s waterfall project management. This quadrant chart maps out the real ROI of that heavy administrative overhead. On the x-axis, we track the setup and documentation effort. On the y-axis, we track predictability and code quality. The standard vibe coding approach drops right into the bottom left. It requires extremely low effort to start, but yields low predictability when things get complicated. If you are a solo developer building a quick weekend prototype or a single-file script, you should avoid SpecKit. You will spend more time generating tasks and checking boxes than it would take to just write the code yourself. But look at the top right quadrant. For professional engineering teams building complex, multi-file software systems, SpecKit is a perfect fit. The high upfront effort yields maximum predictability and drastically reduces debugging time. The reality check is simple. You are permanently giving up the fast, chaotic rush of the initial prompt to gain rigorous, dependable engineering consistency. If you are tired of babysitting AI through compounding errors and are ready to start orchestrating it to build reliable software, spec-driven development is the necessary next step. You can find the installation instructions and supported integrations on the SpecKit GitHub repository. Subscribe to the channel for more deep dives into the frameworks shaping the future